Hello, everyone. Wanted to make a quick video for you just to derive the half angle identities for us. If you are in my morning class, we were able to derive this cosine of 2 theta one, or sorry, it's the sine of x over 2. And if you're in my later morning one, the 10-10, we weren't able to do any of these. So I just wanted to go through and kind of show you both of these again. So if I wanted to find the sine of x over 2, to derive that one, we are going to start with a double angle identity for cosine of 2 theta, and we're going to use the one that has the sine squared of theta in it. Now, our goal here is going to be to solve for sine of theta. That's what we're going to be doing. So if I want to solve for the sine of theta, I'm going to have to get that by itself. First thing I'm going to do is subtract that 1 from both sides. So I'm going to have the cosine of 2 theta minus 1, and I'm going to have negative 2 times sine squared of theta left over here. Again, I'm trying to get to sine of theta, so the next thing I'm going to do is divide both sides by negative 2. And then I want to get rid of those negatives, so you can either think about factoring a negative out on the top, or if you want to multiply top and bottom by negative 1. I think that might be a little bit more clear for a lot of people's brains. So I'm going to multiply by negative 1 over negative 1. Negative 1 over negative 1 is just 1, so I'm not changing the value. I'm just making it look a little different. So I'm going to get negative cosine of 2 theta plus 1 all over a positive 2. That's going to be sine squared of theta. And from here, to get sine of theta by itself, I am going to take the square root of both sides. And so we get that the sine of theta is plus or minus the square root of negative cosine of 2 theta plus 1 all over 2. And to kind of see how we get to the to our half angle identities here, I'm going to use that x equals 2 theta, which means that theta is x over 2. And I'm going to plug these in both here and here. So what happens now is that we get, I'm going to write this side first, we get that the sine of theta, and again, theta is x over 2, is equal to plus or minus the square root of negative cosine of 2 theta plus 1. I'm going to rewrite that and put the 1 first. So it's 1 plus a negative cosine of 2 theta, and 2 theta is just x all over 2. This is our half angle identity for sine. So we just got that by solving the double angle identity here for sine squared. And similarly, if I wanted the one for cosine of x over 2, I'm going to start with a double angle identity for cosine again, but I'm going to use the version that has cosine squared in it. And again, I'm just going to solve for the cosine of theta. So to start getting cosine of theta by itself, I'm going to add that 1 to both sides. So I'm going to get the cosine of 2 theta plus 1 equals 2 times the cosine squared of theta. And again, I want cosine of theta by itself, so I'm going to divide both sides by 2. That's going to give me the cosine squared of theta over here. And now I'm trying to get cosine by itself, so I'm going to square root both sides. And so I get plus or minus the square root of the cosine of 2 theta plus 1 over 2 is equal to the cosine of theta. And again, I'm going to make these same substitutions here. So x is 2 theta and x over 2 is theta. So I'm going to plug that in both of these. And I'm going to get that the cosine, I'm going to start with this side, the cosine of theta, and theta is x over 2, is equal to plus or minus that square root of, again, instead of cosine of 2 theta plus 1, I'm going to write that as 1 plus the cosine of 2 theta. 2 theta here is just x, so I'm going to put an x in there instead, divided by 2. And that is our half angle identity for cosine. Um, just wanted to kind of show you that. And then if you wanted to figure out where the tangent came from, I'll run through that real quick for you as well. The tangent of x over 2 then would be the sine of x over 2 divided by the cosine of x over 2, which is going to be plus or minus the square root of 1 minus cosine of x over 2 divided by 1 plus the cosine of x over 2. And again, we're just going to keep change flip. And since this is division in here, I can put the square root with the top and the bottom. So when I keep the top, it's going to be the square root of 1 minus cosine of x over the square root of 2. I'm going to change this big division bar to multiplication, and I'm going to flip the bottom. And when I flip the bottom, again, I can put the square root with each of these individually across that addition or across that division. I can do that with division, but not addition and subtraction. And so from here, my root 2's cancel. I'm going to keep my plus or minus. I end up with the square root of 1 minus cosine of x all over the square root of 1 plus cosine of x. And the one I gave you in class just writes that whole thing over one square root instead of two separate ones. So I can just get rid of this one and put one big one over everything. And so that's where this one comes from. I hope that helps, and I will see you on Friday for more half angle identities.